Miss Collier explains.
Experimental probability.
Today, our learning intentions are to understand what experimental probability is and how it relates to the theoretical probability of a large number of trials, to be able to find the expected number of occurrences of an event, and to be able to find the experimental probability given the results of an experiment. We will know we are successful when we can calculate the expected number of occurrences of an event and when we can calculate the experimental probability of an event. Experimental probability. Probability in everyday life. We have looked at theoretical probability, which tells us what should happen in different situations. But we know that if I flipped a coin 100 times, it is very unlikely that I would get 50 heads and 50 tails. That's because every flip would have a 50-50 chance of being a heads or a tails. But the coin doesn't know what I've already flipped in my previous goes, so every time is still 50-50 for either option. This is what we call experimental probability, what actually happens when we actually conduct the experiment. So as we just said, the theory of probability rarely ever finds it to be exactly so in real life. Sometimes for different events, we might not be able to figure out the exact probability of an event, but we could carry out an experiment and then use those results to estimate the probability. The experimental probability fraction looks almost the same as the theoretical one, but instead of the numerator being how many times the event could occur, it is now how many times the event did occur. So we would still write PR event in brackets, how many times it did occur on the top, and the total number of trials on the bottom. If we wanted to calculate the expected number of occurrences for a certain event, we could take the probability of it happening and times it by the number of trials in the experiment. Obviously, if the number of trials in an experiment is large, it is more likely to show true results. If I had 10 marbles in a bag and I only drew out 3, that really wouldn't give us the probability of those different marbles in the bag because I don't have a large enough trials in the experiment. If I drew it out 1,000 times, we would get a more accurate understanding of the probability of those marbles. Let's try working with experimental probability. The question says, when playing with a spinner, the numbers 1 to 4 are on it. The following numbers came up. 1, 4, 1, 3, 3, 1, 4, 3, 2, 3. A says, what is the experimental probability of guessing a 3? We start out this question much like our theoretical probability. First, we write PR because we are doing a probability. Then we write the event in brackets, and the event we are looking at is 3. And then we write equals. The only difference for probability is now we're looking at the actual results from an experiment. So the numerator is the number of times the event did occur. And the event occurred 1, 2, 3, 4 times. And now the denominator is the total number of trials that we did, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So that's 4 out of 10. Now we know that probability can be expressed in many different ways, but unless they ask, we usually leave it as a fraction. But we always need to simplify it. Here I'm going to divide them both by 2 to give me 2 over 5. So the experimental probability of drawing a 3 was 2 over 5. B. What is the experimental probability of getting an even number? Again, we're writing PR for probability and writing even in the brackets because that's the event we're looking at. Now, the numerator is how many times this event did occur. I've got an even, and even. That's only 3 times. And the denominator is the total number of trials, which is still 10. I can't simplify that, so the experimental probability of getting an even is 3 out of 10. And lastly, C. Based on this experiment, how many times would you expect to get a 3 if you spin 1,000 times? So this is looking at our expected number based on an experiment. What we have to do is take the probability of the event, which usually I would write PR and then the event. But this is the event I've already calculated the fraction for. So I've already figured out the probability is 2/5. If you don't already have that fraction, you're going to do this like normal. Then once you have the probability, you multiply it by the number of trials you would do, which is 1,000. So I'm going to times by 1,000. And I know to times fractions, I need to put this 1,000 over a 1. 2 times 1,000 is 2,000. 5 times 1 is 5. Now I have to say, how many times does 5 go into 2,000? I'll quickly do some math over here. 5 into 20 goes 4, 5 into 0 goes 0, 5 into 0 goes 0. So that's 400. 400 times. So if I did the experiment 1,000 times, I'd expect to spin the 3 400 times. You have a try. Let's check your answers. When rolling a dice, the following numbers come up: 1, 4, 3, 6, 6, 2, 4, 3. A, what is the experimental probability of rolling a 3? So I'm going to write PR and 3 is my event. How many times did the 3 come up? Well, that's 1, 2 times. And how many events did I have in total? 1, 2, 3, 4, 5, 6, 7, 8. I'm going to simplify that by dividing them by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. So the experimental probability of rolling a 3 is 1/4. B, what is the experimental probability of rolling an even number? So I'm writing PR, even, and how many evens did I have? 1, 2, 3, 4, 5. That's 5 out of 8. 8 because that's the total number of trials. 5 out of 8 can't be simplified, so that's my answer for the experimental probability of rolling an even. And lastly, C. Based on this experiment, how many times would you expect to get a 3 if you rolled the die 80 times? So I've already calculated the probability of a 3, so that's 1/4, and I'm multiplying by 80, and of course over 1. 1 times 80 is 80, 4 times 1 is 4. How many times does 4 go into 80? Well, 4 goes into 8 2 times, 4 goes into 0 0 times. So that's 20 times. If I rolled the dice 80 times, I'd expect to roll a 3 20 times. I hope now you are confident that you could find the expected number of occurrences of an event and that you could calculate the experimental probability of an event.